let's see how we can implement subsample analysis techniques in R. As usual, let's start with specifying our working directory. You already know how to do that. And let's call our dataset, which I call it X. Before starting with subsampling, let's view what do we have in our dataset, view X. Now, as you can see, we have variables in our dataset. These 10 variables are representing actually either 10 statistical population if the data come from a target population, or 10 statistical sample if the data come from a target sample. Now, just to remind you, what do we mean by subsampling? We want to draw a subsample from this statistical population. For example, if I want to have the age of all those observations who are female only, I select all these ages from this statistical population that corresponds to female observation. First, subsampling. If you remember, we said that we have two methods of subsampling. First, random subsampling. Consider a vector that contains numbers from 1 to 10 and randomly select 4 observations from it. The function is being used to subsample is called sample. The vector which I have considered is C, that contains number from 1 to 10. Number of observations that I want to subsample, size equal to 4, replace equal to true. Replace equal to true means a number can be repeated in the subsample. Okay, run this. Let's see what is. S in our case here is 8, 2, 10, and 3. If you repeat this subsampling, since it's random, elements of subsample is changing. Now if you check, each time you subsample, the elements of S is changing. Now let's see how you can apply this in our dataset. Let me call it as gender. It's called sample from X gender, size equal to 15, replace equal to false, because I don't want to repeat one person twice. This subsample, which I call S gender, contains 15 observations randomly drawn from the statistical population gender. You see, I have specified my statistical population or the variable from which I want to draw a subsample, which is gender. Now, if you run this, and if you want to see which observations are being drawn, these are 15 of them. Now, if you repeat the subsampling, the values are keep changing. Every time you run this process, the observations in the subsample keep changing. With this subsample that you have drawn, you can apply all those univariate descriptive techniques that we have covered so far. For example, I can have the frequency table of SG, which is there, female 7, male 8. Or you can apply graphical techniques. For that, I want to draw the bar plot and the pie graph of this sample together using the power function mf row c of 2 in 1. So bar plot t color is equal to c of red and blue. Then I have the pie graph of t color is equal to rainbow 2. Then running all these 3 lines together. Now you can see here it is in the bar plot of the subsample that I have selected. This is the pie chart of the subsample I have selected. Just to see how the things are changing, the observations are changing as I repeat the subsampling. Select everything together, run it again. See the difference. Please observe the differences here and the graph again. Next, let's see the non-random subsampling. Non-random subsampling. In non-random subsampling, as I told you in the lecture, we define a principle based on which we select a subsample. And then we apply our numerical or graphical analysis technique to all subsamples that we draw. For example, I want to subsample the working hours based on the gender. Now let me call working hours for females only. I need all those observations in working hours for which the gender is equal to female. I want to have all those observations in working hours, X working hours, for which gender is male. Now you see I have defined two variables, WF and WM. WF, now this is containing the working hours of the females only. Obviously this is a subsample of the variable working hours. WM containing the working hours of the males only. Obviously this is also another subsample of the working hours. In order to compare the working hours of females against the working hours of males, we can apply all those univariate descriptive techniques. Let's start by plotting their graphs together. Plot density of working hours male. Let me give it a color blue, and then let me add to this density plot the density of working hours female with color to be red. In order to distinguish the two density plots, let me add the legend. Put the legend in the right position. Let me put it in the 10, 0.4 position. Let me give the titles, first male then female, color equal to C of blue and red, LTY is equal to C. Okay, let me plot this, plot this, plot this. Now you see here in the graph we can see the distribution of the working hours of males versus the working hours of females. The first conclusion, the mean of the working hours for the female employees is larger than the mean of the working hours for male employees, because the peak for the male employees it's here and the peak for female employees it's here. Second, it seems that the variation in the working hours for female larger than the variation in the working hours of males. Third, there is no extreme outlying value in none of the subsamples of male and females. Apart from graphical techniques, we can apply all numerical techniques such as measures of location, such as mean of WF, which is 8.55 hours, and mean of male, it's 8.2. The two values confirms our previous discussion on the fact that the mean of the working hours for females it's larger than the mean for working hours of males. Let's compute the standard deviation of the two variables. It's 1.04 is d of working males, it's 0.86. Now, if you remember, I just told you that the variation in the graph C, it seems that the variation of the females working hours is larger than the variation in the males working hours. And the standard deviation of the two, if you compare here and here, 1.04 for females, 0.86 for males, it's clearly the standard deviation for females is larger. In addition to these, you can compute other numerical measures such as skewness, quarters in order to compare the distribution. You can also use these graphs in order to compare the distribution. You can calculate any other numerical measures that we have covered in the class in order to compare the two subsets.